Hello, a very good evening to all of you. Thank you so much for taking out time and efforts to join our webinar today. Minimac Systems Private Limited is a company based in Pune. Mr. Anshuman Agrawal is the managing director here. Anshuman is an BTech engineer from IIT ISM, an executive MBA from IIM Indore, an MLT1 trained from ICML, and also MLE from Noria Corporation. He's very passionate about mechanical equipment, fluid power, innovation in technology, and product development. His dynamic leadership always focuses towards addition in skills and resources, improvement of capabilities, development of competencies within Minimac and its team members. We have a vision to spearhead technological evolution towards zero mechanical breakdowns, and we believe in discern, design, and deliver. So let me present to you Mr. Anshuman Agrawal to discuss more about oil flushing and take your questions after the presentation. Thank you.
Thank you so much, Bhavti, and thanks a lot, Minimac team, for inviting me here for the largest international webinar on advanced oil flushing. I'm glad to be a part of this forum where more than 20-25 country participants I can see have already joined here. People all across the globe, and it's great that the organizing team of Minimac has ensured that the timing selected for this webinar is a convenient one, wherein people from all the 6 continents can be a part of this forum, and they can enjoy, they can learn, and they can also solve a lot of their doubts on the topic of advanced oil flushing. So without wasting any more time, I would like to start off with the presentation right away. So the presentation would be on lube oil flushing, myths, challenges, and the right practices. There is a short content out here. First, we would be talking about pursuit to system purity. Then we would be taking up 3 live cases of flushing failures, which we have encountered over the last few years. We would also like to discuss 6 common myths around oil flushing. Of course, the challenges associated with oil flushing. And we would be ending the presentation with summarizing 5 cornerstones of oil flushing, which if followed by the professionals around the globe, they can always have an efficient flushing for their projects and their sites. Pursuit to system purity. So what do we understand by system purity? System purity means elimination of all the unwanted contaminants, not just from your fluid or from your oil, but from your complete lubrication system and the associated equipment. So with this, we want to say, just by cleaning the lubricant or the fluid, we are not going to achieve system purity. So for system purity, the entire internals, the cavities, the pipelines, the component internals, everything needs to be pure and purest to the level or the standard that we are aiming at. So what is flushing? Flushing is a high velocity, sudden gush of velocity. A sudden gush is very important out here. So sudden gush of low viscosity fluid through the pipelines, through the components, or through cavities. So with this definition, we can understand that flushing doesn't just happen for pipelines. Flushing happens for the entire system, and the cavities, the components, pipeline internals, everything is a part of the system. So flushing with high velocity, that's for the entire system and not just the pipeline or the piping. 3 live cases which I would like to discuss here. The first case out here is from a refinery project which happened in Oman few years back. The project slipped its timeline because of improper compressor flushing. This was a turbo compressor installed in the refinery. Because of improper flushing, the total impact on the project was a number of days it got slipped, And also there was a financial impact of $5 to $6 million. The second project is from India. It's a steel plant project where the commissioning team was installing a turbine driven blower. And this turbine driven blower had a lube oil system for the turbine. That particular system was not flushed properly. And because of that, the entire project got slipped by around 1.5 months because they had to perform the flushing once again. As the flushing was not done properly, a lot of bearing components got jammed. The total impact of improper flushing on this project was around $10 million. The third project is a thermal power plant from India. This thermal power plant is having EH control system. The EH control system is for the purpose of governing of the steam turbine. Due to the EH fluid degradation, there was a lot of stuck-up problems for the servo valves. Because of sludge, because of varnish in the system, the valves were not operating freely. Due to this, the plant went on an outage, and there were at least 10 servo valve failures, which were recorded during a span of just 10 months. The total impact on the project was around $3 million. So with these few cases, we are trying to sensitize the audience in terms of how flushing is important for your project, for your running plant, for your rotary equipment, for your lubrication machinery. Now let us have a poll out here. So there's a short poll. I request the audience to please share their responses. We have another 15 seconds. So you could just read the poll question and answer it in yes and no. At the end of 15 seconds, the response would be recorded and we would get the result of the poll. So oil flushing is only a pre-commissioning activity. Of course, a lot of us have mentioned that it's not a pre-commissioning activity only. Now, I'm not surprised because a lot of people around the globe, they certainly believe that lube oil flushing or oil flushing is just a pre-commissioning activity. Of course, it's correct, but it's not only a pre-commissioning activity. This is a myth around the globe that people relate flushing only with the pre-commissioning activity. But as a matter of fact, flushing is highly required, not just during your pre-commissioning, but also during your plant shutdowns and turnarounds. It's required during the breakdown maintenance activities, after you have completed your repair work and you have recommissioned your equipment. At that moment, you will require flushing. And it's also required when you replace your oil in terms of grade changes or in terms of oil manufacturer changes. So there are 4 different activities when oil flushing might be required by your plant. Another poll, I request the audience to feed in their responses in the same energetic manner they have done for the poll number 1. We await the responses for the next few seconds. Great. So we have our responses out here. So a lot of us believe that on-site oil flushing is redundant if rotary equipment was factory flushed and tested by the OEM. A lot of people believe that it's not just redundant. So let us see what's the myth around this particular question. It's certainly a global myth. A lot of people believe that once the equipment is factory flushed, it's delivered at their site, there might be no requirement of flushing further. As a matter of fact, we all know that whenever the equipment lubrication system is installed at the site, the lubricating points would be far away from the lubrication system. So the bearings or the other lubrication points, they would be maybe around a few meters away, and you would have to do some installations with your pipeline network at the site itself. So while you have received your equipment from the OEM, that's the lubrication system and the bearings which are pre-flushed at the factory by the OEM, the network pipeline or the piping which you construct or erect at the site, it might have a lot of welding spatters and debris inside. We have also seen that the project sites, they last for a very long time, and the pipelines are stored in open yards where they might catch rust, or a lot of dust might be deposited in the internals of these pipings and pipelines. So that's why when you weld them together at the site itself, it's very important to flush these pipeline networks before you start your equipment. So even if your equipment or the lubrication console or the turbine bearing or the manifold system, it was flushed previously by the OEM, it becomes very important to get it flushed at the site after you have erected the entire system. It is highly possible that you can loop the bearings out of the on-site flushing activity. You may loop out the entire lube oil system out of the flushing activity, but certainly it is important to flush the pipings and the pipeline network at the site before you start your lubrication system and the rotary equipment associated with it. Time for another poll. Yeah. So oil flushing is a redundant activity if chemical cleaning has been performed properly. I request the audience to feed their responses in between yes and no. Another few seconds before the system gives out the results of this poll. Yeah. So we have the poll result in front of us. Now let us understand the myth around this particular question. A lot of us do believe that chemical cleaning is the ultimate activity, and if we have performed chemical cleaning properly, we have actually got rid of performing oil flushing further. However, it needs to be understood that chemical cleaning happens with the help of chemicals, water, and many other substances or liquids. So while you have completed your chemical cleaning activity on the system and its pipelines, there are huge chances that the chemicals and the water which you have used during the activity, they would be trapped in the nooks and corners of the system. It has been seen multiple times by the commissioning engineers that whenever they start their lube oil system after performing the chemical cleaning activity, if the flushing was not done properly or it was ignored completely, the first time run of the lube oil system might have a risk of the oil getting mixed with the chemicals or with the water which had been used during the chemical cleaning process. This would lead to very hazardous situations where the oil might get emulsified with water, the oil might get degraded because of the chemicals in the chemical cleaning agents, and thereby at the start or at the very commissioning of your equipment, you would have a failure of your lube oil system because the lube oil has already got degraded. It has lost its lubrication properties. So there you might have to engage further equipment for purification and removal of the unwanted foreign material from your lubrication system. This would add to your further activities of the project commissioning if you have not done the flushing after the chemical cleaning activity. Time for another poll. So efficient oil flushing happens at a very high pressure. How many of us believe that efficient oil flushing requires a very high pressure mandatorily? Let us feed in our responses. Just few seconds before we get the poll results. Okay, so we have our responses between yes and no. So 39% believe oil flushing can happen at a very high pressure, and 61% believe that it's not very important to have a high pressure. So let's see the myth around this pressure parameter. So efficient oil flushing certainly does not happen at a very high pressure. Rather, it happens would see how turbulence is important for flushing and how turbulence is related only to the flow rate and not to the fluid pressure. It's important to generate a turbulent flow in the internals of the pipings and the cavities which have to be flushed. And thereby we need to create velocity and not pressure for performing oil flushing activity. At a lot of sites, we have seen that people use pressure testing equipment, which are at a very high pressure. But normally the pressure testing equipment can sustain a very low flow rate. Although the pressure sustenance is very high, the flow rate is extremely low. And with these equipment, if you perform the oil flushing, you would end up doing the high pressure testing once again, but certainly you would not be able to complete the oil flushing efficiently because the flow rate through the piping is important. There should be a movement of fluid in a turbulent fashion inside the piping. If we just create a high pressure, it would certainly test for us the hydro test for the pipelines, for the leakages, but certainly it would not solve the purpose of flushing. Time for another poll. Poll number 5. Oil flushing flow rate is decided based on the largest diameter pipeline of a lubrication system. This is a very interesting question, and I would be glad to see the responses of the audience out here. Whether it's the largest diameter or the smallest one or something else. Let's think about it and give our responses. I'm very glad that the team has got this poll feature this time, because this would help me to connect to the audience very well. Thank you so much, audience. So a lot of us believe that oil flushing flow rate is decided based on the largest diameter of the pipeline of the lubrication system. Well, thank you so much. Let us understand the myth around it. So here I would like to draw out a very important point, that although the audience is thinking a little different from what I think and what the normal flushing flow rate is decided based on what. So oil flushing flow rate is certainly decided based on the largest diameter pipeline of the lubrication system, but that's not the only point we need to check. This might be true in a lot of cases. In majority of flushing applications, the largest diameter pipeline would give you the right flushing flow rate for doing the flushing activity of your system. But there are a lot of cases where you have multiple loops, multiple branch lines, multiple bearing points, which would come out of the manifold, the discharge manifold or the supply manifold that we call. So a lot of branch lines, when they come out of the branch manifold, of the discharge manifold, the entire flow rate which we have calculated for the largest size diameter of the pipeline that would get divided. The entire flow rate would flow into multiple branches. So are we ensuring that the flow rate which is going into each of these branches and each of these loops is having sufficient velocity, is having sufficient Reynolds number for each of these loops to ensure a good flushing, to ensure turbulence? We are not sure about it. Hence, it's very important to check out the complete lube oil circuit, not to follow what your client has advised. A lot of times the clients would say that the largest size of my lube oil system is 4-inch. So you as a contractor, you as a service provider would go there calculating the Reynolds number based on the viscosity for a 4-inch diameter pipeline. And when you reach the site, you start the flushing, you understand that 4-inch was just the manifold line, but there were maybe around 7 to 8 1-inch or 2-inch diameter branch pipelines where your flow would get divided because you have to perform flushing in a fast track manner. And thereby you would land up feeding just a 10th or a 20th of the demanded flow rate for these branch pipelines. Thereby your flushing would be improper. The ultimate sufferer would be your client, because if your flushing is not done properly, tomorrow the client would face a lot of problems with regards to those branch lines which could not be flushed properly. So it's very important first to understand the entire lube oil circuit which you have to flush. It's very important to check out each of the branch lines of these lube oil circuits. A very interesting equipment which our teams have normally encountered, and that's called Phe Heat Exchanger. So these heat exchangers, they have multiple cooling tubes. Normally the inlet port and the outlet port of these heat exchangers is 4-inch or 5 or 6-inch. But the tubes, the cooling tubes, they might be of 1-inch diameter. One of these ACHE, air-cooled heat exchangers, we can see here, it has got multiple tubes, and these tubes might be some 60 or 120 in number. And the oil, when it is fed into these heaters, these heat exchangers, it would get divided into the multiple loops or into the multiple tubes. Thereby the entire flow rate would be diminished to less than a 10th as per the requirement of each of these tubes. So how are we ensuring turbulent flow inside each of these tubes? Unless we do a calculation of performing flushing on these heat exchanger tubes, we must not follow the advice of handling the port size and based on that calculating the flushing flow rate. Time for next poll. So this is probably the last poll we would be having during this webinar. Oil flushing is all about attaining and generating report on NAS 1638 or ISO 4406 for oil cleanliness. So oil cleanliness tests of NAS and ISO 4406, they are required for oil flushing and nothing else. A very major question for the people out there who would be performing flushing for various sites globally. Do we just require to test the oil? Okay, so we have the response out here. It's almost mixed. A lot of people believe that oil testing is a major criteria. So let us see the myth around this question. So as per our experience around oil flushing, we do honor the two standards of NAS 1638 and ISO 4406 for checking the quality of fluid which is being used for the oil flushing activity. Well, that's one of the major tests and one of the major milestones which every professional of oil flushing must follow. But at the same time, we would like to address a very important parameter which one needs to inspect in a proper fashion, and that's mentioned in the API 614 standard. And the test is called mesh inspection. You can see the mesh photograph down there, and you can also compare the results. So the results on the NAS and ISO tester, they were pretty good. They were in the range of NAS 5, NAS 6. However, the mesh screen told a different story because the mesh is actually handling the entire flow rate what you are feeding into your pipeline system. It is normally installed for inspection on the final return side of any of our flushing loops. And hence, it checks the contamination which is returning from the piping loop in totality, while the NAS and the ISO 4406 tests are performed on a very small sample size, which might be between 100 milliliters to 500 milliliters. So it depends a lot on when and from where this 100 to 500 milliliter sample was drawn. If it was drawn from a wrong sampling point, and at the same time, if it was drawn at a wrong time, because in flushing, we would understand that generation of particles can happen very intermittently. So if you are drawing the sample from the piping network, when the cleanliness was established, you might be drawing a wrong sample. Whereas after you have drawn the sample, there is a high probability that there would be a sudden gush of further contaminated fluid which would return from your flushed line. Hence, it's important to have a primary clearance using a mesh inspection. Although it's a very conventional technique, but till date, it's one of the most reliable ones to give primary clearance to any oil flushing activity, and it's also mentioned as a part of API 614 standard document. So one has to count the number of particles or foreign contaminants which get trapped on this mesh, and based on that, you need to clear the first stage. And of course, after you have cleared the first stage, you certainly have to go for NAS testing and ISO 4406 testing as prescribed by your OEM or by your client. So ending this topic of myths around flushing, we are moving forward to common oil flushing challenges. To my knowledge, there are 3 common oil flushing challenges which I would discuss right now. Oil flushing is a milestone activity, and it being a milestone activity, there's a lot of financial concern around the flushing activity for the service providers, for the contractors, and also for the end users. Due to this fact, many times the site personnel try to rush the oil flushing activity, considering it as a formality activity. Now, that's certainly a big challenge for someone who wants to perform oil flushing in a proper regulated fashion. Many times the oil flushing activities, they take a certain amount of longer time because of the fact that the pipeline contractor had not welded or fabricated the pipeline in a good fashion. A lot of times because the chemical cleaning contractor had not done his job in a proper fashion. So oil flushing, although it is the last milestone in the pursuit of preparing your system for commissioning, it is one of the most important and the last check activity in your pre-commissioning schedule of activities and tasks. So as it's a milestone activity, you might always face a sudden rush around it, but it's important for us as technocrats to understand the fact that oil flushing cannot happen in a rush situation, but it can happen only if it is performed in a well planned fashion. The second challenge which we have noted down is oil flushing has to be performed yesterday. Now, that's a very common statement which has come from a lot of flushing professionals or the commissioning professionals. The reason to it is they could not plan the oil flushing activity in advance. And that's the reason why they had to land up in a situation where they are caught unprepared. They might not have the right equipment to perform flushing. They might not have the proper plan to perform oil flushing. And in a lot of cases, probably they had ignored oil flushing completely by bypassing that milestone activity. And they got caught when their equipment broke down at the very instance they started it up. And thereby, in order to fulfill their project commitments, they want to perform it as fast as possible, or rather yesterday. The third and the most important challenge around oil flushing is there is an acute shortage of specialized equipment and manpower which can perform flushing for your plants. The reason is the same. Flushing has not been a very active activity in the plants, and it's rather a very ignored or neglected activity by a lot of professionals. And hence, there are very few companies or very few contractors who are trained enough to perform the flushing requirements for your plants. So moving forward, we would like to give you a certain mantra or Bible or cornerstone for performing the oil flushing for your plants. There are 5 cornerstones or 5 mool mantras which you can use for your projects. It can be a lube oil flushing, it can be hydraulic flushing, it can be your special synthetic fluid flushing like PAG fluids or EHC or phosphate ester or any other fluid which you are using in your rotary or hydraulic system. The first cornerstone is you need to decide the flushing flow rate. The flow rate has to be decided keeping in mind that you have to achieve a certain Reynolds number. So what is Reynolds number? Reynolds number is a factor which defines whether your fluid flow through a pipeline is having a turbulent flow or not. For having a turbulent flow, the common Reynolds number which professionals use around the world is 4,000. So for achieving a 4,000 Reynolds number, you need to calculate the velocity of the fluid. And when you have calculated the velocity of the fluid based on the viscosity and the diameter of your piping network, you can easily calculate the flow rate based on the velocity which you have calculated from the Reynolds number formula. There are certain calculators available online as well as with the Minimac team, which can be requested for having this online calculator for deciding how much flow rate is required for your pipeline while you're performing flushing. So over the chat box, you may please send in your email IDs as a request if you would like to have these calculators on your email box. The second cornerstone for oil flushing is fluid viscosity. We all know that when the fluid viscosity goes down, the Reynolds number would be much better. And hence, we need to have a lower fluid viscosity so that we can develop a better flushing flow rate and we can have a better Reynolds number or a better turbulence in the pipeline. The third one is oil temperature. The fourth is efficient filtration. And the fifth one is testing, fluid testing. So we would be capturing all these 5 cornerstones over the next 5 slides. The first one, flushing flow rate. We have already discussed about the Reynolds number. It has to be more than 4,000. The second one, we had briefly touched upon this point while we were discussing one of the myths. So as you can see, this is a pictorial representation of a piping network where the central line or the central cord line, that's one of the largest sized diameter pipelines, but the branch lines, they are much narrower or thinner. Now, when you calculate the flushing flow rate across each of these branch lines and add them up, you would land in a situation where the flushing flow rate calculated as per each of these branch pipelines, that certainly would come more than the flushing flow rate calculated through just the main header pipeline, which is at the center of this network. The third one, we had discussed about the pressure as a parameter during flushing, when we were discussing the myths. So flushing pump certainly should have a very good flow rate, but at the same time, it should also have the pressure handling capacity, because you would be handling your flow rate into various nooks and corners of your piping network. In various cases, you might have very long pipings. There might be situations where you would have your piping going in a vertical direction upward. There might be situations where you would be doing some umbilical flushing, where you would have, say, kilometers of pipeline, not just meters. So in those scenarios, it's very important to have sufficient pressure for your pump, so that because of these back pressures of long pipelines or vertical pipelines, you might not lose the flow rate what you have already planned for your flushing activity. So flow rate is certainly the most important parameter which you need to check, but at the same time, your pump should also have the power to have the pressure sustenance to handle the pressure drop or the back pressure from the flushing loop. The second cornerstone is fluid viscosity. We have learned about it earlier, that low viscosity fluids, they enhance the turbulent flow in the pipeline, and hence it is important to have low viscosity of fluid for performing the flushing. The third one is oil temperature. The first point under oil temperature is that we all know that when you lower the fluid temperature, the viscosity goes up. And when you increase the fluid temperature, the viscosity goes down. So preferred temperature is always on a higher range. And that's why we call flushing activity as hot oil flushing activity. Because when you heat up the oil, you're actually reducing the viscosity of the fluid, and thereby you are having better turbulent flow rate in your pipings. The second point, when you have temperature variations in your fluid, you are actually having a thermal shock for the internals of the pipings. Now just see the cross section of the piping which has been shown down there. When you offer a higher temperature for the fluid, there would be a certain expansion because of heat. And this expansion would be higher for the metal pipings, and it would be lesser probably for the debris which is sitting on the internals of these pipings. So because of this difference in coefficient of expansion for the debris and for the piping internals, there would be a loosening effect on the particular debris which is sticking to the internals of the pipings. And when this happens, you are ensuring that the loosened debris would be flown away or washed off by the flushing fluid which you are using for your flushing application. The third one is mechanical shocks along with thermal shocks. So when you perform the thermal shocks using temperature variations on your lubrication system, you can also have mechanical shocks using some pipeline vibrators or manual hammers. With this, you are ensuring a better loosening effect on the debris. So down there, you can see a picture of a piping which was flushed, and you can see the difference, what happens after flushing. Efficient filtration. So we all know that filtration would be required during the scope of flushing, because when you are flushing, you are actually capturing a lot of debris from the piping network. And when the fluid is returning on the downstream of your flushing loop, there would be huge amount of debris in it. Hence, it's very important to understand how to have filtration or how to capture this debris at the right time. Because if you do not clean or filter the debris out, the same would keep on rotating in the pipeline and flushing would never conclude. So to ensure a super clean fluid on the upstream of flushing or the flushing loop, you need to have stage-wise filtration after the downstream of flushing loop. You need to collect it efficiently. By the term efficiently, what we mean is you need to have stage-wise filtration for the debris, wherein you can have coarse stage as the first stage, a medium filtration at the middle stage, and very fine filtration on the third stage, which would ensure that you have better life of your filters and at the same time a very cost effective filtration for your flushing loop. What is beta ratio and what is dirt holding capacity? For every filter that we use, it's very important that we make the right selection of the size of the filter, the capacity of the filter, the life of the filter. A lot of people get confused by the lube oil system filters, which are already installed on the lube oil system. It's important to understand that the normal lube oil system filters are not designed to handle the heavy debris which is getting generated during the flushing process. And hence, you need to go for oversized filters when you are using them for flushing activity. If you don't use oversized filters, the filters would get clogged very easily during the flushing process. And normally all the filters have a bypass. And then when the filter starts bypassing, you might not come to know that your filtration has stopped. So as a matter of fact, you would continue to do flushing without filtration because the filters have got bypassed. The last cornerstone of efficient oil flushing is fluid testing. So fluid testing, we have also learned in the previous slide, it should happen in 3 stages. The first stage is API 614 mesh inspection. Initially, your mesh would have a very high debris content. You need to install the mesh at the right place. Normally, it is installed on the return side or the downstream of the flushing loop so that it can handle the entire flushing flow rate. The mesh must be removed easily for the inspection activity and must be placed back after the inspection has been performed. When you have very tight project schedules, you can plan for at least 4 to 5 such mesh spoons so that your activity is not stopped while you are performing the inspection through the mesh. The second test, which is very common for the hydraulic systems or the EHC systems, that's called the NAS 1638 test for fluid contamination. Normally, the OEMs or the contractors would have a prescribed standard in terms of what NAS quality should be detected on the flushing fluid in order to declare it completed. The third one is ISO 4406. Again, this standard is similar to NAS, but it's more common for the lube oil systems. So let us see what a typical flushing circuit looks like. It would have oil reservoir with heater. It would have oil pump, then the flushing line filter, the entire pipeline system which you have to flush. Then the fluid goes into the return line filter, and finally it is returned into the reservoir tank. It is better to have external flushing systems and not to use the lube oil circuit for performing the lube oil flushing activity. Because if you use the same lube oil pump for your oil flushing activity, there is a high chance that your existing auxiliary oil pump or the lube oil pump would be subjected to heavy debris, and that might reduce the lifespan of your equipment components. We have compiled certain international standards and documents which are very important for oil flushing activity. These are certain ISO standards for flushing and cleaning of pipelines, for hydraulic systems and for lubrication systems. Then we have ASTM standards, which are used for various hydraulic and lubrication systems as well. The third one is MIL standard, normally used for the hydraulic power transmission equipment. Apart from these international standards, we have two common manuals or procedure documents from General Electric Company and from Solar Turbines Company. So these two companies have their own standard manuals. But in a nutshell, all these manuals would be talking about the same 5 cornerstones that we have discussed already with you in the previous slides. So when you perform oil flushing based on these standards and these manuals, you need to take care of these 5 major cornerstones that we discussed in the previous slides. Next few slides, we would be talking about the company Minimac Systems. So Minimac Systems was incorporated in 2012. It's a startup recognized under the Government of India. As Bhavti, the host for today, she mentioned, the vision for Minimac is to spearhead the technology evolution towards the zero mechanical breakdowns in industrial machineries. To have this dream come true, we accelerate the adoption of cost-efficient technologies and practices, which would improve the reliability and performance of lubrication and hydraulic systems. The products that are offered by Minimac Systems, they offer oil purification systems, they offer flushing systems, filtration housings, filter replacements, oil testing and monitoring equipment, and process equipment for the fluid processes. The services and consultancy offered by Minimac team, you can also see on the photographs, equipment rentals and site contracts for various flushing and purification activities, also performing oil analysis both on site as well as in the laboratory, and of course technical consultancy and expert manpower services. Some of the oil purification equipment, so there are 5 different technologies which are offered: simple mechanical filters, coalescer based separators which can free up the free water content from your lubricating oil, electrostatic oil cleaners which are very popular for removing submicronic particles, and also sludge and varnish. The FRF or EH oil conditioners, which are commonly used for phosphate esters in power plants. So these can help you to reduce the total acid number, moisture contamination, and of course, you can also maintain ISO 4406 and NAS 1638 using the FRF conditioners. And the last one is vacuum dehydration systems, which are used for removal of all three forms of moisture from your fluids. Some photographs of external flushing skids. We have seen at multiple sites that the professionals, they uh, fabricate the flushing skids at the site. They lay down some ad hoc arrangements by loose pumps, filters, heaters, control systems at the site itself. And many times these sites are controlled under ISO norms for health, environment, and safety. And under those situations, such ad hoc arrangements are not approved by the end user or the site owner. So in these situations, you can go for standalone, external, combined systems, which can be used for flushing application. And normally these systems are equipped with everything which is required for flushing, including the reservoir tank, the pumping system, a high flow pump, heaters to ensure a high temperature, efficient filtration in 3 stages, and equipment to detect the oil quality or the NAS class or ISO 4406 class. These equipment are available in almost all the flow rate sizes, right from 10 liters per minute to around 20,000 liters per minute. And these can be used for various applications of lube oils, hydraulic oils, synthetic fluids. They can be used in multiple environments. Your project sites might be explosion proof environments, which come under the category of ATEX, or they might be offshore environments wherein these skids would require offshore certifications. So as a matter of fact, these Minimac skids normally have all these certification options, which if requested, can be offered to the clients. So thank you so much for hearing me out. I am sure most of you, or maybe all of you, would have gained something or more from this short webinar of 1 hour. I welcome you to put forth your questions. We have a Q&A section. You can check it out on your screens of laptop or your mobile devices. You can jot down your questions in the Q&A section. We have yet another 30 minutes where we would like to answer your questions and resolve your doubts. Thank you so much, audience. Over to the host.
Thank you so much, Anshuman. That was a wonderful presentation. Let's quickly, without wasting time, take on some of the questions we have. We have Mr. Reddy asking, is there any time period in oil flushing?
Thank you so much, Mr. Metu, for this question. The time period is something which is decided by the site owner or the project controller. However, flushing time period is decided by the contamination which is sitting inside your piping and your components. So unless you are sure about how much contamination is there in your piping, no one can estimate what time period you would require for flushing. Normally, the time period is not defined in any of the manuals. However, the time period for thermal shocks is defined in a lot of manuals. So during this time period of thermal shocks, you can increase the temperature, you can decrease the temperature as per a certain cycle. And after the conclusion of thermal shocks, if your purity level of fluid on the downstream of flushing loop is achieved, you can of course get a permission from your site owner to conclude the flushing activity. Otherwise, there is no predefined time period for concluding the flushing activity.
Great. Next is how low the viscosity is recommended to go for oil flushing.
Thank you so much for this question. So viscosity as low as possible is good for oil flushing, but at the same time, you need to understand that this viscosity needs to be compatible with the lube oil or the lubricant that you would be filling in your system after you have concluded the flushing activity. So if you are using a different fluid for having the flushing activity to be performed, and that different fluid is much lower in viscosity, you need to be sure that you have evacuated this flushing fluid from your system before you fill in the lube oil into your existing system. Because if you have not evacuated that low viscosity fluid from your system, there are chances that that low viscosity fluid would be hiding in the nooks and corners of your piping network, and that would mix up with your lube oil when you start your system. So you need not go as low as possible by the use of a different low viscosity fluid, but you can follow the instructions on your manual and use the same fluid for performing the oil flushing activity.
All right. The next one we have is from Mr. Ramakrishnan. He has two questions. Are your flushing skids operate as modular unit as part of a plant or a standalone portable system based on application? In your experience, what is the time required for drawing sample to API 614?
Okay, thank you so much, Mr. Ramakrishna, for both the questions. The second question regarding the time frame, I believe that has been answered. The time frame is not predefined, but depends on the contamination what you observe. So if you can follow the API 614 manual, there is a certain section which talks about the amount of particles or foreign debris which you are inspecting on the inspection screen or the mesh screen, and based on that you can conclude flushing. And the first question regarding the modularity, so as a matter of fact, flushing skids are temporary skids which needs to be fitted or hooked on to your system for a short duration of time when you are performing the flushing. This might be during the pre-commissioning phase, this might be during the shutdown phase. So they need not be a part of your system. But if you feel there are certain systems in your plant which need to be flushed very regularly, like I have come to know that there is a system used in the offshore industry and also in the oil and gas industry, where the hydraulic system of the wellhead control panel, it needs to be flushed very regularly because it's a safety device that the hydraulic system controlling. So for these systems, the flushing needs to be performed at a very high frequency to a level of maybe once in a week, because it's a safety precaution one has to do. So for such systems, the fitment of the flushing system is very important, and it needs to have a proper plan according to the project site requirement, based on the size availability, based on the piping network that you are laying down at the plant. So for such requirements, yes, the flushing system needs to be a part of your plant. But for any other systems where the flushing is not a very frequent activity, it might be an annual activity, you can keep the flushing system as a part of your plant in your yard and use it as and when required. As a matter of fact, the flushing system flow rate must be defined, or it must be pre-decided to serve almost all the systems that you are having in your plant. It should not happen that you have purchased a flushing system which is suitable only for certain systems of your plant, and when you go for other systems, it is not suited to them. So based on these understandings, you might go for a flushing system purchase or design or procurement.
Thank you. The next one is from an anonymous attendee. Is there any possibility of increased flushing performance by pulsating flush oil flow?
Yeah, this question is a great one. Pulsating flush flow is, of course, something which generates a fluid shock in the system. So, over and above turbulent flow rate, if you can create pulsations by having intermittent flow, by having pulsation effect, that would certainly add to the flushing efficiency. However, if you cannot perform the pulsation, even though if you can perform the turbulence, you are certainly ensuring a good flushing for your system. So pulsations are important for increasing the efficiency, but they are not a mandatory parameter or not a mandatory feature which you need to have for your flushing.
Okay. Mr. Raj wants to know, please advise how to choose mesh ranges from the primary flushing to final flushing. In final flushing, which range of mesh is best?
Great. And I can also read a question apart from Mr. Raj, a question from Mr. Nishant Wag, where he has talked about beta ratio. So beta ratio of the filtration. So I would take up both the questions together. The micron rating which you select for your filtration and the beta ratio, which is actually the efficiency, these should be taken into consideration based on the amount of debris which is getting generated by your flushing. Normally, we decide it based on the type of system that we are going to flush. So many times it comes with experience. For example, I can mention here some of my experiences. If we flush a lube oil system, which is done up with some carbon steel piping, we can expect a huge amount of debris getting generated in such lube oil systems. So it's mandatory to have large or coarse size mesh or micron ratings for your first stage filtration that can go to the level of 60 micron or even above. So when you are doing it for your carbon steel pipings, you can expect very large sized particles in your flushing application. When you do it for the stainless steel pipings of the lube oil system, you can expect that the particle sizing would be much lesser because of the welding type that you have used for laying down or erecting these pipings. So you can start with a 25 micron filtration and further go down to 10 micron, and later on for your final flushing, you can go down for around 3 or 6 micron. Now the selection of the fine filtration certainly depends on the end criteria of ISO 4406 and NAS 1638. So if your end criteria for flushing is NAS 6 or NAS 5, you might be required to go for a 3 micron filtration as the final stage of filtration, having a very high beta ratio between 200 to 1000 beta ratio. And these beta ratios should be rated, certified by the right agencies. You must not get caught by the fraud claims by a lot of filter manufacturers around the world who have not got their beta ratio certified or the micron rating certified by the ISO 16889 standards. So it's very important to select the filters based on the right micron rating, the right beta ratio, and also the right manufacturer. I hope the questions have been answered well.
Thank you so much for answering that in detail. And let's take the next one. Giving thermal shocks by heating and cooling of oil will also assist flushing, right? If yes, how it can be scheduled?
So while you have started your flushing activity, initially you can start it without having any thermal shocks. After having certain cycles, once you have ensured that the already loose particles have been removed from your flushing, you can start the thermal shocks. So while you start your thermal shocks, normally you follow a procedure or a cycle of how much duration you should go for high temperature and what duration you should go for low temperature. For selection of these time frames, you normally follow the procedure which has been prescribed by the OEM of the equipment that you are flushing. So you could always refer to the standards what we have mentioned, because there is no one single rule for all the systems for the time frame or the cycle of thermal shocks, because every system is different and every piping has different kind of debris in it, and thereby based on the system that has been designed by the OEM, the thermal shock cycle is also predefined, and you need to search for the flushing manual where the thermal shock cycles have been defined, and you can follow them. Thank you.
Great. The next one is from Mr. Ramakrishnan. How do you estimate back pressure on flushing pump? Is it through as-built drawing?
Thank you so much for this question, Mr. Ramakrishnan. So when you plan your flushing activity, as I had mentioned earlier, that you need the P&ID or the flow diagram of every component. You actually calculate the rough flow rate based on the flushing flow rate of your pump in each of the branch lines, in each of the components. Based on the P&ID, you can easily understand what would be the pressure drop across each of the components when you will be passing your flushing flow rate through them. You need to understand a very major fact out here. Lube oil systems normally are designed for lower flow rates as compared to the flushing flow rates. So for example, if a lube oil system has a lube oil pump of around 1000 gallons per minute, you might be flushing that same system with double the flow rate of around 2000 gallons per minute. For such situations, there would be expected higher pressure drop against each of these components which are a part of the flushing loop. We also know that as a matter of fact, we loop out or we bypass the bearing points and a lot of sensitive components from the flushing loop. So thereby you are left with what? You are left with only the pipeline and the loops through which you need to calculate the back pressure. For calculating the back pressure, there are certain online softwares which you can use. You can feed in the fluid viscosity, the fluid type, the diameter of each of these piping loops, and the flow rate, the temperature which is passing through the loops. And thereby you can calculate the pressure drop across each of these components. And based on that, you can decide the back pressure that would be generated during your flushing application. And certainly you need to go for sufficient pressure handling capacity of your pump before you go ahead for your flushing activity.
Great. Mr. Suleiman wants to know, can oil purification be carried out in parallel with oil flushing? I believe oil purification is already a part of oil flushing.
Yeah, that's true. And with oil purification, if Mr. Suleiman wants to talk about filtration, so yes, filtration is not just a part, but it's a very important part. However, if Mr. Suleiman wants to refer to removal of moisture or removal of other liquid components or liquid impurities from the fluid, we need to understand that removal of water contamination or removal of acid contaminants from the fluids, they are a very slow process. Their flow rates are very low. So if you are performing these separation activities of liquid to liquid at the time of flushing, you might not get the right efficiency. So while you have to remove the solid debris at the same flow rate at which you are performing the oil flushing, for removal of liquids or water contaminants or acid contaminants, you might perform it once you have concluded the flushing activity, or maybe before you have started the flushing activity. Because flushing is not related directly to addition of water or addition of acids. Flushing is related directly to addition of debris, which is stuck in the internals of pipings. However, many times if air blowing activity has not been concluded properly after the chemical cleaning activity, you might encounter addition of water contamination as well when you have started flushing. So in such situations, you might have to stop the flushing activity. You might have to remove the emulsified content of water from the fluid, and only after that you might be allowed to restart the flushing activity, because flushing with emulsified fluids would be highly dangerous. A major reason is to that is flushing normally happens at high temperatures. If you perform flushing at high temperature using an emulsified fluid, which is having water content in it, there might be chances that you are actually breaking your entire flushing fluid because of degradation. And hence, it's very important to first de-emulsify your lubricant, de-acidify your lubricant, and only then perform the flushing activity. Suppose you don't have the purification equipment to do that at your site, you might have to go for a different batch of lubricant for performing flushing activity. I have personally seen at a lot of sites where the contractors had to go for a different batch of lubricant because they did not have any purification equipment at site to de-emulsify the fluids. I hope the question has been answered in the most comprehensive manner.
Yes, certainly. Mr. Kumar wants to know, how do you match the required flow rate of client site with your skid pumps? I mean, do you have any flow control?
So yes, a lot of flushing skids, they do have flow controls. These flow controls can be using electronic flow controls, where you can control the RPM of the flushing pump motor. So you have variable frequency drives, which can reduce the RPM of the motor which is driving the flushing system pump. So with that, you can actually control the flow rate electronically. You also have bypass valves on the flushing skids, with which you can bypass a major amount of flow rate if you want to reduce it. And with that, you can control the flow rate. However, as a matter of fact, I would prefer the first option, where you use electronic control using a variable frequency drive for controlling the flow rate of a flushing pump. Because when you use manual valves for reducing the flow rate, there is a high chance that your pipeline back pressure would not be able to be handled by the flushing pump because of the recirculating line which has got created on the flushing loop. So if you have to reduce flow rates, it's preferred to go for VFD systems on the flushing pump motor. If you are going for diesel engine operated pumps, so there again you have systems with which you engines and thereby reduce the flushing pump flow rate. If you're using hydraulic pumps for doing or performing hydraulic flushing, there are hydraulic controls on the special hydraulic pumps like axial piston pumps or the vane pumps. So these hydraulic controls can also be used for controlling the flow rates of the flushing pump.
Very well. Mr. Hariharan wants to know, most service providers prefer to have single flushing systems to serve their clients with length, diameter, number of main and sub pipelines. Can they really use single system for all pipeline, or the flushing system must be custom made for each client's pipeline system?
That's a great question from a service provider perspective, because service providers normally prefer to have a single system or common systems for all their sites, so that they don't have to plan their assets in a much detailed fashion, because they really don't know what sites they would be encountering in future. However, it is preferred to categorize your flushing needs into 2 or 3 different categories based on the application of the system that you might be flushing. So suppose service provider is more commonly doing flushing for lube oil systems or turbine systems or compressor systems, they might be encountering large diameter pipelines mostly. So they can plan for a system which is in the range of 2000 liters per minute to 4000 liters per minute if they are going to do flushing for large size turbine systems or compressor systems. If a service provider wants to perform flushing for hydraulic systems, there are hardly any hydraulic systems where the requirements would go beyond 1000 liters per minute. For such contractors, going for a variable frequency drive controlled flushing system between 200 to 1000 liters per minute should be sufficient enough for their flushing requirements in the hydraulic systems. And based on these applications, based on the market survey, based on the sites that these contractors or service providers would be serving, they need to plan for the right sized flushing system. But unfortunately, if you're planning for just one system to cater to all your needs, all your application areas, all your environments, all your installations like offshore, onshore, and everything, you might land up in buying a large sized elephant, which might be used in future for very small sized jobs. And thereby the application or the resource utilization would not be efficient. So it's better to have multi-sized equipment for multi-sized requirements, but based on a smart selection, based on categorization of the jobs, what you want to perform in future.
Great. I'm sure Mr. Hariharan would be happy to have that answer. Nadeem wants to know, can we use existing used oil for flushing purpose, provided that the oil is tested and found fit for use?
Yes, of course, Nadeem, we can do that. And 80% of the people certainly do that. When you have multiple equipment in your fleet to be flushed, you buy a common fluid batch which can be used for flushing for all these systems. If you have just one or two systems to be flushed, you can use the same batch of fluid that you would be filling tomorrow in those systems, and you can perform the flushing using the same fluid. And certainly the rider out there, you need to test the fluid beforehand for all your properties.
Great. We are running a little short on time. We'll take last 5 questions. Mr. Haight wants to know, what is the better oil cleaning system for 4000 liter hydraulic oil tank?
So for oil tanks, if you want a filtration system, you need to go for something which can circulate the oil in a 1 day time, in a 1 day duration. So this is certainly something different from flushing. If you want to do a filtration in a tank, which is a standalone tank, of course, in the future webinars, I would be taking up this topic in much detail in terms of filtration of tanks. However, as you have asked this question, what I can say is you can multiply 4000 by 7. So it becomes 28,000, and you can divide it by 8 hours of operation in a day. So that would give you somewhere around 3000 liters per hour. So that's just a thumb rule. And based on that, you can use your filtration system. So that's coming around 3000 liters per hour. That's the filtration flow rate, which is recommended for a 4000 liters tank. And that's certainly something which is very empirical based on a calculation from our own field experience.
Great. Mr. Sanjay wants to know, how do you estimate time period for greenfield systems?
I think we have taken up this question earlier as well, so we can skip on to the next question.
All right, sure. Mr. Patrick wants to know, what pressure is required for oil flushing, less, greater, or the same as the pipe operating?
So normally you can experience a higher pressure drop in a pipeline. So if you want to compare it with the pressure during the flushing operation, you can expect that it would be a little higher than the pressure which is experienced in the normal designed piping. However, it needs to be understood that there is no requirement to generate the pressure by throttling the pipeline loop. There is no requirement to throttle it. There is no requirement to have a return line valve and close it to the half, because pressure does not assist flushing. So your pipeline should be a free flowing pipeline. Whatever pressure is getting generated on your flushing pump, it's basically because of the pressure drop it experiences, the flow experiences across your pressure components of the system. So, however, normally we have seen that the pressure of the piping during flushing doesn't go very high as compared to the normal operation of the pressure of the piping loop, because a major amount of pressure drop components like bearings, like certain special valves, they have been bypassed as a formation of jumper loops. So thereby those pressure drop components have been reduced. Thereby the pressure experienced on a pipeline loop might be almost the same or a little more because of higher flow rate.
Okay, that's great. I'm going to take up a question from the chat box. Dear sir, in compressor lube oil cooler, we have a lot of thin fan tubes. We have any specific flushing methodology for cooler tubes? I think you've already covered this up during the
for cooler
presentation.
tubes, yes, we need to understand what flushing flow rate we need to go for. That's very important point. I have actually not come across any procedure manuals for checking the cooler tubes. However, I have seen one company where our company had performed the flushing in Oman. So there is a company called Jord. They have a standard methodology for doing the flushing of their air-cooled preheaters, air-cooled heat exchangers. And these tubes or these heat exchangers, they have a standard methodology for doing the flushing application. So of course you could get in touch with your OEM of the heat exchanger and they can help you out with the procedure. As a matter of fact, what we have with us, the only point what you need to understand is when you calculate the flow rate required for heat exchanger flushing, you need to calculate each of these tubes flushing flow, add them up, and then use the right flushing flow rate pump for doing the flushing of these tubes.
All right. Mr. Bashir wants to know, there is any chance that a bigger oil consumption circulation system, is it possible to attach permanently on that equipment, for example, big turbines or compressors?
I could not understand the question in terms of bigger system.
I think he wants to know if this flushing system could be permanently attached to an equipment like big turbines or compressors.
We had discussed during the initial questions that it can be used as a permanent installation if your flushing is very, very critical and you need to perform it very regularly and a very high frequency. So it's a great thought to have a permanent flushing system at your site. And if you do that, you can certainly flush each of your systems on a regular fashion during the shutdown activities, after each of your breakdown maintenance activities. So one system certainly required, but whether or not you need to mount it at one place, it depends on how far away your rotary equipments are. If they are too far away, then it's not needed to mount it at just one place, because flushing systems, they are as near to your rotary equipment as possible, because normally the flushing systems don't have very high pressure pumps, because if they have a very high flow rate, the pressure has to be compromised. If you want to have a flushing system with very high flow rate and very high pressure, you might land up in buying a very costly elephant. So it's better to go for movable, portable flushing system, which can be lifted by your cranes. And that's why you see the pictures what we had shared on the slides. They all are liftable by the cranes, by forklifts, and many times they are also movable on wheels. So better to keep them as portable systems for your entire plant. However, if your system is too critical and you have planned for a flushing system for that particular system as a parallel operation, then of course you can go for permanent installations. A lot of people do that. So one of the applications which I shared earlier, the wellhead control panels, there's a mandatory requirement of flushing system on each of the rigs for the oil and gas industry.
All right. And the last one for the evening, what's the disadvantage in doing flushing using my lube oil system AOP?
AOP. So AOP of your lube oil system has been designed for a much cleaner oil comparatively to the flushing fluid. And these will lose their life if you subject them to a very high amount of debris. Normally, your AOP manufacturer, the OEM, would not recommend you to use the AOP for high debris fluids. So why to lose the life of the AOP for doing a job which can be done by a separate system, which can do it in a much efficient manner? The second reason is, while you're using your AOP, I'm sure you would be planning to use your existing lube oil filters as well. And reminding you once again, the existing lube oil filters are very small in size. Plus, they might not be in multiple stages. So you might land up choking huge amount of existing lube oil filters, which probably would be costlier than your flushing filters. And hence it's better you to go for a separate flushing system, which will actually bypass your AOP. It will bypass your entire lube oil system. In fact, it would serve as a alternate, a temporary alternate to your lube oil system. I believe there are still a lot of questions which we could not answer because of lack of time.
Yes, there are a lot of questions, and we would actually like to get in touch with everyone and get your questions answered by Mr. Anshuman as soon as possible. We'll reach out to you over emails and over messages on LinkedIn. And guys, if you have any queries, if you want to book a consultation by Mr. Anshuman and our technical expertise, I would really expect you to reach out to our website and drop us an email at inquiry@minimac.in. Inquiry@minimac.in. That's the email ID. You must reach out to us in case you need any help with lubrication reliability or contamination control. We will continue to educate a lot of people around the globe towards lubrication reliability, and our journey will continue. Thank you so much for joining with us today and giving us the time and the honor to present and discuss oil flushing. And thank you so much, Anshuman, for a great presentation.
Thank you so much, everyone. Bye-bye. See you once again. Thank you so much.
Thank you. Goodbye. Have a good day.